In this video, we will be looking at the nature of the roots, and this is aimed at algebra in grade 11 and 12 mathematics. Now let's start off. Before we can discuss the nature of anything, let's discuss what a root is itself. So, discussing roots, we need an example. I'd like you to consider the function of g of x being the quadratic function, or the parabola rather, of x squared minus 4. Now if you remember from grade 10, when we sketched the parabola, it was a smiley face. And x squared minus 4 is now presented on the screen. Now what we need to see, a root is actually the point where your function intercepts the x-axis. This being your x-axis. And x squared minus 4 will cut the x-axis at minus 2 and 2 respectively. So that means its roots are actually the x-intercepts. And for this specific graph, it's at x equals minus 2 or x equals 2. Alright, so now you are aware of what a root is. Now let's discuss the nature of the root. Alright, now we're going to discuss the nature. Now, if I had to ask you, what is your nature? I'm asking you for a way of describing yourself, your personality, who you are. Whether you are timid or short-tempered, so on and so forth. And to build up to telling you how to discuss the nature of the roots, I need to show you a simple way of getting roots. This is called the quadratic equation, and this, like I just said, is a way of finding the roots, a shortcut of finding roots. Okay, it's a generalized formula. But if we look at this, there's a whole bunch of letters here. I mean, why? So we have x, which we know is going to be our root, right? X equals minus b plus minus b squared minus 4ac over 2a. It's a whole lot of letters. It sounds like we're about to make a letter salad. No. What it's building up to is the basis of our function. So let's say we have f of x, which now just jumped onto the screen. If you remember, in grade 10, we introduced the quadratic function as ax squared at standard form plus bx plus c. And here we see those letters are repeated. Fantastic. So what it's actually telling us is we have an a, we have a b, and we have a c. A is your coefficient of your x squared. B, the coefficient with the sign, don't forget the sign, of your x, and c is your constant with its sign. Alright, fantastic. So, if we had to sub that in, it would go in there, and we would be able to find our root, which is x. Okay, so that's finding the root. Now, to find the nature of the root, we can use the quadratic formula and dissect it further. Now, we need to take a look at the discriminant itself. Alright, and the discriminant is based on what is underneath the square root of our quadratic formula. Alright, we can use this to analyze what is actually going on with our roots. What is their personality? Alright, so that is represented by the symbol delta, this triangle over here. And that is the symbol for the discriminant. And it represents b squared minus 4ac. Now, looking at that, we can discuss what the roots would actually be without solving them. So, if delta is greater than 0 over here, that means we have real roots. And having real roots simply means that we have x-intercepts. They exist. The graph would cut the x-axis. That's what that means. So, if delta is greater than 0, cool, we have real roots. However, if delta is less than 0 now, it means we have non-real roots. If something's not real, it just means it doesn't exist, right? Think about that logically. If we get a negative under the square root over here, it's your solution here is gonna be undefined, which means it's not real. What that looks like graphically is your parabolic function would just cut over there. It would never cut the x-axis. That's what that means. So the nature of those roots would be they are non-real, meaning your function does not cut the x-axis. That's what that means. Alrighty, let's go take a look at the next one there. Now they tell us if delta is equals to 0. Well, in theory, that means we would have equal roots. Alright, And what that means is you only have one x-intercept. Alright, which if we had to look at the mother function of the quadratic formula, it's where it cuts the origin, where it touches the x-axis once. Cool. Now, if delta was a perfect square, that means the roots would be rational. And if delta was not a perfect square, well, then that means irrational. Alright. Now, that is it for the theory. Let's go put it into practice. And so I present you with the first example. Determine the nature of the roots of, and this is the function we mentioned earlier over here, 2x squared plus 3x plus 1. Okay, now to get the nature of these roots, we need to look at delta. And what is the formula for delta? B squared minus 4ac. Memorize that, please. We don't give you that. Alright, A, B, C. Now we need to substitute in and solve. And if you remember the whiteboard tutoring essay, we always say when you substitute in, put brackets in the place of whatever you are taking out. We are replacing A, B, and C with their values. So let's put brackets in the place just to make sure that BODMAS never fails. That's why we put those brackets. Okay, so B is 3, A was 2, and C was 1. And when we apply BODMAS and solve this, we get 9 minus 8, which equals 1. Alright, now we needed to discuss the what? Did we need to solve the roots? No, we needed to discuss the nature of the roots. So let's take a look at this. Is 1 greater or equals to 0? Yes, it is. It's definitely greater than 0. So therefore, the roots are real. Why would I say that? Well, if it's greater or equals to 0, we are over here, which means the roots are real. Cool, that's one part of the nature. Now, let's take a look at the other one. What else do we know about 1? Well, 1 over there is a perfect square. Why? Let's look at perfect squares quickly. 1 is equals to 1 times 1. 4 is equals to 2 times 2. 9 equals to 3 times 3. I'm sure you know where I'm going with this. Let's say 36 equals to 5 times, I'm lying, 6 times 6. Okay, so perfect squares are these numbers, 36, 9, 4, 1. They are numbers that are the result of squaring another number. So 1, yes, it is a perfect square. And what does it mean if it's a perfect square? It means it's rational. So the roots are real and rational. And let's see if there's anything else we can say about them. Let's go through our list here. And this is what you need to do always. You need to go through the list. Greater or equal to 0? Check. We mentioned that. Is it less than 0? No. We don't need to say anything about non-real. Is it equals to 0? No, it's equals to 1. We mentioned the perfect square, and we can't say not perfect square if we mention perfect square. So the nature of the roots is it's real and rational because delta equals 1. Alright, that's way too easy for grade 11 and grade 12 level. That was just to consolidate the theory. Let's apply it in a test level question. In your test, they're going to ask you something similar to this. They'll say the solution of a quadratic equation is, and here it's provided that x is equals to 3 plus or minus 4 minus 8p over 2, and they ask us determine the values of p such that, and let's start at the first question, I'll get to the second one later. Focusing on the first question, the roots of the equation are equal. Now, if the roots are equal, what does that mean? That means that delta has to equal 0, right? Where is delta? Please never forget delta is under the square root there. So if delta was equals to 0, then we could simply substitute what is under the root in place of delta. Do not go and try and get a, b, and c alone. It's not necessary. You simply need to just apply what is under the root. 4 minus 8p equals 0. And they are looking for values of p. So get p alone. Therefore, 4 equals 8p. And to get p alone there, we divide both sides by 8. So 4 over 8 equals p. Simplifying 4 over 8, 1 over 2 equals p. Bam. 2 marks. Just like that. So easy. Okay. Now the next one they said determine the values of p such that the equation is non-real. and using what space we have left there, let's try that. For non-real, that means delta has to be negative, right? Less than 0. Why? Because we can never have a negative under that square root. Alright, so that means if delta is less than 0, it has to be 4 minus 8p is less than 0. Now we're working with an inequality, so we just apply those rules. 4 is less than 8p, which then translates to, we divide both sides by positive 8, so the sign will stay the same. 4 over 8 is less than p, which means that a half is less than p. Or remember, when we word these, we could also always focus on the p, so p is greater than a half. Alright, ladies and gentlemen, thank you so much for watching. Please like, subscribe, and share, and become part of the Whiteboard family. Cheerio!